Hello, welcome to the Site of EVA webinar on building a region of interest or regions of interest and building spectral libraries. These spectral libraries will be built manually, meaning the user determines what spectra are in the library, as well as the regions of interest. So first I'm going to start off by opening ENVI. Then I'm going to go to File, Open Image, and we're going to use the AUNP Cell 60X. So once this file opens, I'm going to demonstrate first how to build a region of interest. Now, a region of interest is an area in which you outline either by hand or by using shapes, and you want to obtain spectral information from this region, like an average, a max or a min, or plus and minus standard deviation. So we can use these regions of interest to get mean spectra of large areas very quickly. And we can also use these regions of interest to save all of the individual spectra that are in the region, meaning each pixel within the region will be outputted to what's called a spectral library. Now, just to give you a quick lesson, a spectral library in ENVI is also known as an end member. So whenever you see end member collection or end member in ENVI, what it really means is a spectra of interest, and it usually comes from a spectral library. A spectral library is nothing but a file that contains multiple spectra or one spectra, but usually in most cases multiple spectra. And this spectra is of interest. It represents something. It represents either an area of the spectra of interest or spectra from a certain material. For example, you would collect many spectra from a particle of a certain size, let's say a 50 nanometer gold particle. You would collect many spectra from these gold particles and save them into a spectral library file. Then these spectra would be searched for in other areas to look for spectral matches. And we'll go over some of those routines that do spectral matching later, but we're going to start from scratch here and just sort of start with building a region of interest and getting mean spectra and then going to a spectral library. So here I'm going to use this cell with gold particles as an example again. And what I'm going to do is we're going to concentrate on a couple of particles over here. And we're going to show you how to use the region of interest tool. So the first thing you want to do is decide, do you want to build this region of interest in the zoom window or in the image window? I find it easier to do it in the zoom window. So to do this, to access the region of interest tool, just like the Z profile spectrum, it's right-click in any of the windows, and right beneath Z profile spectrum, we see the ROI tool. This is the region of interest tool. So we click on this, and the region of interest tool comes up. And the first thing we see here is it automatically has region 1. And what this is going to do is assign a color to these regions, or region, because you can make many regions. And it's going to tell you how many pixels are in that region, as well as points, and if it's solid, and the orientation, and the space in the image that it defines. But the main thing is you're going to want to know maybe how many pixels that it represents. Up here in the top, the region of interest can be drawn in the image window, the scroll window, or the zoom window, or off. You would want to turn it off because sometimes if it's always on and you go to move, let's say, the zoom window or move something in here, it will automatically start drawing and it can be annoying. So I always turn it off at first. And I position my zoom window where I want it, and then I'll click zoom. I'm going to draw the region of interest in here. I can zoom in on a particle, and the type of region of interest is here in the ROI type, and we have polygon, polyline, point, rectangle, and ellipse. And you can probably guess what these are all going to do, but I'll show you. Polygon is the default, and if you left click and hold and draw freehand around a particle, that's polygon. And then when you almost complete it, you let go, and if you right click one time, this green bullet shows up here in the center, And you can actually left-click this now and move this around, or put it back into its original position, or not even move it. If you right-click a second time, it fills it in. And so here we have 44 pixels. Go down here to the next particle. Draw freehand around this particle. Right-click once, twice, fills it in. Now we have 77. Go down to this particle here. Right-click once, twice, and it fills it in. Now with this region, we can get the statistics from this region, meaning the min, max, plus and minus standard deviation, and mean. And to do that, we just highlight the region and we hit the stats button. Now, it's going to take a second, but it's calculating this data for these 94 pixels. And when it's done processing in this window, it's going to pop up all 5 of the spectra, the min and max, the standard deviations, and then the mean. So if we expand this out and we show the plot key, we see the min and max are in red, plus and minus standard deviations are in green, and the mean is the white, this curve here. So to get these spectra out by themselves, for example, most people want to see the mean spectra, we can right-click the inside of this ROI statistics result window and go to Options, New Window Blank. And again, like we talked about in one of the ENVI basics tutorial, now that you have this new window blank, you can just click the mean and drag it into this window. And so this is now the mean spectrum of these 3 particles here. And of course, like we talked about, you can go to Edit Plot Parameters, and we can name this. And then we can go to Edit Data Parameters and name this as well. So that's how to do the Polygon region of interest. I'm going to close these, and I'm just going to go ahead and delete this region of interest. And we can go to Polyline, and Polyline is just a straight line in which each pixel that this line is touching is collected. We can do points, which are individual points. And of course, you can imagine rectangle and ellipse are pretty self-explanatory. Ellipse can either be, stretched, or you can make it into a perfect circle. Now, what if you want to collect more than one region? Meaning I collected more than one region, but it's part of region 1. So, for example, let's take these 3 particles again and do a polygon around these. These all pretty much look the same to our eye. They have this kind of golden color. And I'm going to hit New Region now, and let's go to a completely different part of the image here. Let's go to this area down here. And I'm going to draw a big region here. So I've got 252 pixels I collected here as opposed to the 61 pixels of those gold particles, but just to kind of show you how this works. In a real situation, you might want to match the number of pixels to be fair, but for this, I'm just going to show you quickly how this works when you do 2 regions. So I have 2 regions, these 3 particles here and this larger area here of whatever this stuff is. And I want to compare these 2 regions. Now, when you get the statistics for one region, you get a mean, but you also get a max, min, and the standard deviation. When you do 2 regions, so I'm going to hold down Shift and highlight 2, or I can just hit Select All, and I'd hit Stats, it's only going to give you the mean comparison. So I'm going to let this run, and when this is done, we'll have the mean of region 1 and the mean of region 2 compared to each other. And here we go. Here it is. So now we have a right-click to show the plot key, the mean of region 1 and region 2. And we see that obviously there's intensity differences, these particles, these gold particles, which is what these yellow and red particles out here are gold particles. And this area here, these are actually aggregated carbon nanotubes, and then this is a cell. So we're kind of comparing the spectrum between these carbon nanotubes in green and then these gold particles, and we obviously have a big spectral difference, but there's also an intensity difference. These gold particles are scattering a lot more light than the carbon nanotubes. So that's how to use your region of interest tool. And again, we can add more to these very easily by hitting new region, and then we can come over here to something like, let's see, let's go over to these two particles here that seem to be a little more red. So we highlight these particles, select all, stats, and now these regions will be compared. Instead of 2 means, there'll be 3. And it'll be the difference between the original gold particles, these gold particles that look to have a little bit more red shift, and the carbon nanotubes. And so these particles here in blue do have a peak of around 635 nanometers. I'm getting this number from this bottom left corner. Remember, when I left click on a plot, it shows these numbers in the bottom left corner, and this peak is, I can zoom in, remember, by middle mouse clicking and holding down, I can draw a box around. So this is around 639, this peak is around 611, and this carbon nanotube really doesn't have a peak. If it did, it would be around 600, I would guess. So again, this is a way to collect lots of spectrum and get a mean very quickly using a region of interest tool. Now we're going to talk about how to collect a spectral library. So a spectral library, like I mentioned, is a collection of spectra that you're interested in. You probably want to identify the spectrum in another image or another sample or maybe somewhere else in the image in which the spectral library came from even. So to collect a spectral library, there's several different ways you can make a spectral library. There's a manual way, which I'm going to show you now, and then there's a way that you can collect spectra from regions of interest. So what I'm going to show you first is how to do it manually. So this would be by accessing first the Z profile spectrum window, which is done by right-clicking in the zoomer image window, the shortcut menu. And then, in one of the ENVI basics tutorials that we did earlier, I showed you that if you right-click in the spectral profile window, you go to the Collect Spectra dialog. Now this means anytime you click on a spectra, it's going to be saved. So here, I'm going to collect these spectra. I can jump down to this particle here, collect all the spectra associated with this particle, and then jump down to this one, and so on. So if you do it this way, which is the manual way as I call it, because you're actually having to click on the individual spectra that you want to collect, it creates this window in the spectral profile window, creates a bunch of spectra of interest. And then to save this into a spectral library file, it's very simple. You just go to File, Save Plot as Spectral Library. So you select all. There's 18 spectra I collected. OK. We can either save this to memory, which means it'll just show up as a memory file in this available bands list, or we can name it. So let's just go ahead and name it. So on the desktop, I'm just going to name this AU-NP-SLF1. Now, SLF means Spectral Library File. It's not an extension. It's just a naming system I use to keep my files straight. Because you're going to have pretty much 3 types of files, for the most part, associated with your sample. You're going to have the actual data cube, which would be this AU-NP cell 60X-1. This is the actual data cube, the hyperspectral scan. And then you're going to have files associated with this scan, like Spectral Library file. And then eventually a classification file, which is once you have the spectra of interest, there are algorithms that will search for the spectra in the spectral library in this image or in other images. And those are called classification files. And we'll talk more about those later when we go into spectral search algorithms like peak location classifier and spectral angle mapper. So for now, I'm just going to save this spectral library file with the nomenclature SLF1. And I hit OK. And as you can see, this spectral library file showed up here in the available bands list. So even if I got rid of this, I could right-click this spectral library file, and actually you need to right-click not the sub file here, but the actual file, and say Spectral Library Viewer. If you select this, you can click on these spectra. And if you just click on one and then hold the down arrow on your keyboard, it will quickly scroll down and then put all these into a plot, a live plot, spectral plot window, so you can see what spectra you have. But this is now saved. So another way that you can create a spectral library file is by regions of interest. So if we go back to the regions of interest tool by, again, right-clicking, it always saves, by the way, the last regions of interest that you had. So we actually have these here. So what you can do is once your regions of interest are built, you can save these pixels into spectral libraries. So this is a quick way to make a spectral library without having to individually click on the particles and the pixels. So here, I'll just start over. I'll select all and delete. So if I wanted to make a spectral library for these particles down here that were more red, I would just simply have my zoom window selected, ROI type is polygon. I'll just draw around this particle. Draw around this particle. Remember, to close this, you double-click the right-click button. Then I can drag this over to other particles that kind of look red. There's one over here. Maybe over here, this one. So let's say I want to have these 73 pixels in a spectral library. Well, up here in the top main ENVI toolbar, this is the main ENVI toolbar again, you go to Site Viva Analysis, Convert ROI to Spectral Library. Convert Region of Interest to Spectral Library. So you click on it, and it's going to ask what file associated with the region of interest. Well, it's this one we have open, AUNP cell 60X, and you hit OK. And here it is, Region 1. And so now, if there was more than one region, we could add these as well. Spectra will include all pixel spectra. You have the option of just the mean or spectra, pixel spectra and the mean. Usually you just want to do all individual pixel spectra for a library. Output data to integer, that stays the same. Again, we can do this to memory or to a file. We'll just do it to memory real quick. So now this memory file, and if you'll notice, the spectral library files have this icon of a little spectrum in a grid, sort of like the spectral profile. So if we right-click and go to the Spectral Library Viewer, now we have all of these, I believe it was 77 spectra, and if I hold the down arrow, it's going to quickly go all the way down to the bottom. So these are all of the 73 spectra, 73 pixels. So every one of these pixels that I drew in the region of interest went into a spectral library. So this is a quick way to make a spectral library from regions of interest. Well, I thank you, and that's it for this webinar. Have a good day.